Hey guys, welcome back. Last video we talked about, filtering out routes from the ISP that we don't necessarily care about. So if we go back to Internet Router 1, we just get logged in. So where we left it was, we were learning the static default, which we want, but we were also learning all, I'll call it the garbage routes, but we don't necessarily need to know about all these specific routes. All we care about is learning that, right? So we talked about the idea of introducing a route map to filter out these unwanted routes, right? So essentially, when we go under BGP, let me just show you kind of where all the ties are, and then we'll go ahead and we'll build it. So when we go under BGP, under the address family where the neighbor is activated, right? So if we go to the neighbor and we hit the question mark key, we have a whole bunch of options here, okay? One of them is route map. So we can apply a route map to this neighbor. So as we build more neighbors, we can apply different route maps to different neighbors. And that's how we start to play traffic cop, if you will. We can enforce filters, advertise certain things to them, filter out things that they're sending to us, so on and so forth, right? So when we reference a route map, all right, the route map has to be obviously configured as well, or prior, or whatever, right? So if we go into route map configuration, it says, okay, let's build a route map. So let's just call it, we'll call it ISPA inbound. And remember I said I like to always end my route maps with RM, so that way I know exactly what it is, right? So we say route map ISPA in route map, and then we have to say, in this case, we want to permit something, okay? So we just want to permit, it wants a sequence number, so we'll say permit 10, okay? In here, this is where we're actually going to tell it what we're trying to match, okay? So we want to match values from, it says the routing table, but in this case we want to match what we define in either. So we have an option for IP. So we want to match an IP address in prefix list, okay? We can do an access list too. You can do it either way. I'm going to introduce the concept of prefix list because we've already used access lists for things like NAT and that kind of thing. So let's go ahead and we're going to build a prefix list. So this is the next tie. So in BGP we reference a route map. The route map is going to reference a prefix list. Hopefully the prefix list is where we actually define the meat and potatoes of what we want to do. So in the last video I said Cisco nests the functionality. This is kind of what I mean. So we can either work from top down or we can work from bottom up. So in this case, I think it makes more sense to work from bottom up if you guys have never really played with prefix list, route maps, and that type of thing. So let's go ahead and say IP prefix list, okay? Similar to access list and route maps, it wants a sequence number. So we'll just say, IP prefix list. Actually, I'm going to give it a name first. I'm going to tell it what we want to call it, okay? So we'll say IP prefix list, we'll say ISPA in, okay, so we're going to give it the same name as the route map, but I'm just going to tie PL to the end instead of RM. So I know exactly what this thing is, okay? So let's use the question mark, and it says, what do you want to do? We're going to say, we'll give it our sequence, because you can build multiple entries in a prefix list. So let's say I wanted to allow a specific subnet. I can make that subnet and tie it to sequence number, let's say 5, okay? Let me hit the question mark key, permit. So we're saying the first line of the prefix list is going to permit a subnet or a network. We can add another one, right? Another prefix list, which is the same prefix list, but just a higher sequence number, so the next entry. And you can build a sequence number so that you can allow all these different networks, okay? they have their place. Like I said, you're playing traffic cop because you're allowing certain things but denying other things. In this case, all we're trying to do is just allow that default route. So in this case, it wants quad 0/0, okay? So we're saying we're building a prefix list called Internet Service Provider A inbound sequence number 5. We're just going to allow the default route, okay? So that's the prefix list. Now we have to go back to essentially the route map, okay? So let's say route map, okay? So we'll give it the same name, inbound, but in this case it's a route map, so RM, okay? So in this case we're just going to say permit, what do we give the sequence number 5? So we can kind of follow suit. We'll say permit 5, okay? And if we hit the question mark, it says, remember, we have to match. So we're going to say match the IP address in prefix lists, okay? And then it wants to know the prefix list that we're referencing. Well, we just created the prefix list. So let's go ahead and reference the prefix list, okay? And we're going to hit enter, okay? So let's dump out, let's show run section route map. So we now have a route map. Let's get rid of this because we just contradicted ourselves there. Show, we can do show route map too. So we can say show route map ISPA in route map, okay? So this says, okay, we've got this route map that has a sequence number 5 that says match the IP address in prefix list this. Well, what's in that prefix list? We can say show IP prefix list that, and we can see that it's basically defining the quad 0. Okay, so it's that nested functionality. So now if we go back to BGP, under the address family, and we should neighbor 201.111, we should be able to attach that route map, okay? So it wants the name of the route map. What was the name of the route map? It was this, okay? And then you can see it wants a direction. Do we want to apply this route map in the inbound direction or on the outbound direction? Now remember, if we put it in the outbound direction, we're not advertising a default route to the service provider. We're learning a default route from the service provider, and that's all we want to learn from the service provider. So we want to apply this route map in the inbound direction, okay? Before I do that, I want to highlight, right? So if we do show IP BGP, right? Currently we're learning those 3 prefixes. We are learning the default, but we're also learning all of those additional routes, okay? So do show IP route. We're learning everything with a B is what we're learning right now. So let's go back, right, and apply that route map. Again, in the inbound direction, okay? Now if we did this properly, okay, let's do a clear IP BGP star soft, okay? We'll give that a second to kind of converge. And let's do show IP route. So doesn't look like anything's changed yet. Show IP BGP. Okay, so we're learning one prefix, okay, show IP BGP, and look at that. So after a minute or so, right, we are only learning a quad 0 route. Show IP route, okay? So now our routing table only has a single BGP route. And that's the same route that's been in there for 40 minutes. It's from the previous video, but I'm going consecutive here. That's a good sign, right? So we've effectively filtered out I'll call them the garbage routes, right? We don't want the whole internet routing table. We don't need it. All we need is that quad 0 route. So by applying that route map to the BGP neighbor, that referenced the prefix list that matched the quad 0, I know it's a mouthful, we've effectively performed what we wanted to perform, right? We're only allowing or accepting that one route. So it's a good prevention mechanism. You'll see this kind of stuff on internet routers like we're doing here. You'll also see it on WAN routers. Let's say you have a really large WAN environment. Maybe you even have some kind of on-ramp to like Azure or AWS or whatever it may be, you know, and you have to filter routes because you don't want to just start learning this huge influx of stuff. You want to control what you're accepting. This is a use case for that type of thing. Okay, so this is good, right? Let's go back to our topology. There was one other cleanup item that we had to do. So we wanted to, I think at this point we can effectively test full connectivity. We still got to bring ISPB into the mix at some point. I guess we could do that now real quick. Let's just do that so we can wrap up with him as well. So let's open up all the internet routers. Okay. So essentially what we're doing is we're just going to build like a full mesh between the 3 internet routers. And this is just to glorify the lab. This isn't a necessity by any means. So we did that 1111 between A and the loopbacks. All right, so we can do like a 2222 between A and B. Let's just do that. Doesn't really matter, right? And that was what, 4? Yes. No shut. IP address 2222. Actually, we'll stick with the theme. We'll make him 1/30. We already no shut it. Let's go to B. I'm just going to split the screen because it'll make my life a little easier here. IP address 2222/30. Okay, do ping 212.221. Okay, good. So we've got connectivity between him. Let's just do the BGP real quick. Do show run section BGP. All right, let's hop over to here. Let's do neighbor 2222. He's going to be remote AS2. We'll do the opposite for him. So let's define BGP2. We'll say neighbor 2221. He's in remote AS1, and we'll go ahead and we'll activate him. So that should give us a peering. All right, good. We'll throw the network statement in there as well, right? Just so we don't hurt ourselves in the future. Okay. All right, good. Now we have one more peering to do, and that's between loopback and ISPB. Let's check those interfaces. So that's 3 and 3. So interface gig 3, IP address 333. He's 2 in this case. We'll just follow suit, right? Do show run section BGP. We're going to define neighbor 333 1 remote AS3. Wait, Sorry, I think it's 2. Yeah, 2. Right. 2. And then we'll activate him. Sorry, you got to go under the address family because it's already created. Neighbor 3331 activate, and then we'll do the activate. We'll do the network statement real quick, right? Network 3330 mask /30, right? Okay. Do show run section BGP on the ISPB. So let's get the neighbor defined there. And that was neighbor 3332 remote AS 3. Let's activate him. And then let's put the same network statement in here. I didn't do the IP on B, right? Yeah, gig 3, I need to define that IP address. So interface gig 3, IP address is 333.1, or what did I say? 1, yeah. Okay, so we can ping. There's our neighbor. We've got all the networks built. So let's save B. Let's save the loopbacks. And while we're at it, let's save A. Okay. Show IP BGP. Okay, good. So now we have all the /30s that are the triangle of our internet, right? We got the loopbacks for, you know, just to simulate some BGP or internet addresses. And it looks like everything's making it into the table, which is fantastic. So we've got 1s, 2s, and 3s. Okay, good. We've got 1, 2s, and 3s. Okay, awesome. All right, so back to the data center. So if we go back to, I have a feeling that the NAT is probably just incorrect. So let's do this. Let's go ahead and get rid of, I had a weird issue where it might have been me, where I was just defining the access list wrong. So let's just do it one more time. So let's blow him away. We'll leave the NAT on the inside and outside interfaces. I don't think I would have messed that up. Show run interface port channel 1 254. So we know that this is our inside, IPNAT inside. Likewise, we should see 2.901 should be the outside. So okay, so that's obviously good. I didn't mess that up in any way, shape, or form. But let's just redefine the access list. Let's do access list. We'll just say 100. We'll say permit IP. We just want to basically allow everything 10 dot. We'll give it the wildcard to match, and we'll say, what's it, any, right? Okay, good. So then we do IP NAT inside source list 100 to match the ACL we just built. interface, and we want to go out the outside interface and we want to overload him. So let's see if that does the trick. So let's bring up server 1, show IP. We know he's in VLAN 101. He's got the address of .11. He's pointing to the gateway of 254, which should be the HSRP VIP between core 1 and core 2, right? Show run interface VLAN 101. Okay, good. So we know that that's the HSRP address. So first things first, he should still be able to ping his gateway. Okay, good. He can ping his gateway. So let's go one hop further. Let's see if he can ping the firewall. So that would be our exit VLAN. So on the firewall, we have the inside, which is the 254.5. Let's see if the server can ping it. Okay, good. He can ping the firewall inside address. Let's take this one step further, outside address. Okay, that's good. Let's go to the next hop, which is internet 1, right? So the internet connection, well, we can try to ping either one of these. It shouldn't matter, right? So let's try to ping that one. Excellent. He can ping that one. Let's try to ping 201. So far, so good. All right, let's go for the glory. Let's the heck with it. Let's just go straight for 8888. Boom! We did it, folks. We did it. We've got full connectivity from our server all the way out to the internet. Let's do a trace route to see our hard work. Look at that. Awesome. So we don't need to go through all the hops because we just pinged them individually, but we can see it in the trace route. We're now going all the way up to the internet loopback from server 1. So we went to our top of rack switch, which is nothing more than layer 2 switch with a VLAN. It sent it to its default gateway, which we know is core 1 based on HSRP. He's got the static to the firewall. The firewall natted it to the outside address, chucked it over to through Edge 01 up to internet router 1, right? And then through our BGP default route that we've learned and filtered, we were able to get all the way up to 8888, which is the internet up here. That is awesome. Trying to think here. I think we're at a good spot to stop. I think we're going to stop there. I would really love to get Internet 2 in the mix. The only thing we really did not do, by the way, is we have this second internet connection. I guess we really should take that into consideration here. So we got the ISP connection B that was supposed to go to router 2. I guess what we could do is bridge that VLAN over to router 1 and essentially just give him 2 internet connections. I mean, we could do that. So, you know, maybe let's do that on the next video. We'll make one more video dedicated to this. So, because we you know, due to the bug, we kind of lost our hardware redundancy, right? We know it's a valid design, at least I do. It's just something going on with the HSRP stuff. It's just not happy. So what we'll do is we'll bring ISP B, which is I think VLAN 802, right? We need to hop into Edge 02. Oh, he's not even, okay, I gotta boot him. Okay. That's frustrating. I believe it's 802. We can actually check on Edge 01 too. Let's just check. So show VLAN. Yeah, 802. So what we'll do, right? What we'll do is we'll get the IP address assignment on the ISPB, right? We'll put a second IP address on Internet 01. So if we come over here, we will assign port channel 1.802, okay? We'll give him the other address. We'll have a second BGP peering up to ISPB, and we'll build some redundancy that way. So we'll stop here. I'll start a new video. We'll go through that last piece of the puzzle. And with that, we'll have a fully functional, redundant data center. And then the next steps we'll have to consider is the WAN, which we'll get back into the WAN stuff. So thanks for watching. Hopefully you got something out of this, and I will see you on the next one.